Hello students. So today we are going to discuss about the history of transistor. So vacuum tubes are the ancestors of transistor. So nowadays we are using semiconductor based transistor, and in 18th century and 19th century people are using vacuum tubes for controlling purpose. So vacuum tubes are the ancestor of every semiconductor devices. So one of the devices, vacuum tube devices, a vacuum tube diode. So vacuum tube diode is a vacuum tube with two electrodes. Di means two. So it has two electrodes. One electrode is known as anode, another electrode is known as cathode. That cathode is heated by using heater. So this is the actual representation of vacuum tube, and this is a schematic representation of vacuum diode. So inside the vacuum tube you have two plate, one is anode, another one is cathode. The cathode is heated up by using heater. So this spiral indicates it is a heated coil or a heater coil. So this is a vacuum tube, vacuum diode symbol. So it has anode and cathode. The cathode is heated by using heater. So this vacuum diode is invented by John Ambrose Fleming in the year 1904. How vacuum diode works, let us see. And one more device is known as triode. Tri means three. It has three terminal. It has anode and cathode. Apart from anode and cathode, it has one more terminal is known as grid or control terminal. You know very well, electrons are emitted from cathode to anode. Those electrons are controlled by grid. So that is the purpose of grid. So look at the actual representation of triode, and this is a schematic representation of triode. So here inside the vacuum tube there are three terminals. The first terminal is cathode. Around the cathode there is a spiral. That spiral is known as control grid. The outermost terminal is the anode terminal or anode plate. So this triode was invented by Lee De Forest in the year 1906. How vacuum diode works? You know very well, diode has two plates. One is anode plate, another one is cathode plate. And when you heat the anode, what will happen? This cathode plate is heated up. So if I give a supply to this heater will be turned on. So because of that, your cathode is indirectly heated. So due to thermionic emissions, this cathode is ready to emit the electrons. When I connect a power supply like this, your power supply plus is connected to anode and minus is connected to cathode. So this cathode will be negative potential. So due to thermionic emission, your cathodes, it releases more number of electrons. Thermionic emission means when you heat up any material, it emits the electron. So you know very well, your anode plate is connected to positive potential. So this positive potential anode, it will try to attract all the electrons emitted by the cathode. So this is how the diode works. And one more thing, anode is connected to positive potential and cathode is connected to negative potential. So here VA greater than VK, because anode is connected to positive, cathode is connected to negative. So it is forward bias condition. So here there is no electron gain, because whatever the electrons emitted by the cathode is received by the anode. There is no electron amplification. So there is no gain in diode. The second thing is the reverse bias condition. During reverse bias condition, your anode is connected to negative terminal of your battery, and your cathode is connected to positive terminal of your battery. So what will happen? Your anode will become negative potential. This negative potential, your electrons are also have negative potential. Both negative will oppose each other. So these electrons will not be attracted by the anode. Instead of attraction, there will be a repelling force on the electrons. So these electrons, it won't reach the anode terminal. So this is reverse bias condition. So no electron flow. So next lecture we will see